Hello again, everyone. We are dividing the square root and cube root into two parts. One would be to find the square root and cube root of perfect squares and perfect cubes respectively, and another would be to estimate the square root. We would not estimate cube roots because that is hardly required. Binomial techniques would be sufficient, which would be the last part of the advanced calculations. But square roots estimations we would discuss for non-perfect squares. Okay, to begin with, square roots and cube roots of exact ones. So basically, square roots of non-perfect square roots of perfect squares and cube roots of perfect cubes. We will begin with the cube roots because that is, uh, trust me, easier than actually calculating the square root. So for this, first thing that you have to know is that the cubes of all the numbers from 1 to 9. You must be knowing this in order to estimate this value. One second, I'll just write down. Try to write down all of these. Actually, maybe it will take a couple of lines. So I'll just quickly write this down. Now, if you keep observing while I'm writing it down, the cubes of each of the numbers ends with a different last digit, right? So if you observe that 1 cube, it ends with 1, 2 cube ends with 8, 3 cube ends with 7. So each of the numbers are ending with different last digits, right? And there is one more trick that for 2, 3, 7, 8, for these numbers, the last digits are 10 minus the number. So basically 2 cube ends with 10 minus 2, 3 cube ends with 10 minus 3, 7 cube ends with 10 minus 7, and 8 cube ends with 10 minus 8. For every other number, so 1 cube, 4 cube, 5 cube, 6 cube, and 9 cube, for every other number, the last digit is same as the number itself. So 1 cube is ending with 1, 4 cube is ending with 4, and so on. So suppose we take a 3-digit, so suppose we take the cube of a 2-digit number. So one more thing, I mean, when we are talking about cubes, we are talking about cubes of 2-digit numbers only, because 3-digit number cubes are hardly required at any scope of that. So if I take a cube here, 1 2 1 6 7, let's say, and I need to figure out a cube root of this. This is, by the way, a perfect cube. You can test your calculators later on. What we are going to do is you're going to separate it into two parts, the thousands and the rest of it. So 12,167, that is a part, right? So from the 167, so the last three digits, just observe the last digit. So the last digit is 7, right? And if it is from 2378, what you need to do is 10 minus 7. So the last digit being 7, it must be cube of 10 minus 7, that is 3, of a number that ends with 10 minus 7, that is 3. So the number ends with 3 should be the cube root of this number. And now once you have got this, just ignore the last three digits. Now look at this 12. The 12 is more than which cube? It is lying between 2 cube and 3 cube, right? So the 10th digit would be 23, because 20 cube would end with 20 cube would be 8,000 and 30 cube will be 27,000. As this is 12,000 something, so this must be 20 something, right? So the cube root of this number would be 23. Hope that was clear enough. So we'll just detail this with another example. So let's take this number 704969. I think I'm remembering this correctly. Uh, 704969. I think, yeah, that is correct. So if I need to cube root this number, so for again the last digit is 9. This is not from 2378, so straight away 9, the same digit. Okay, so if it is from 2378, then 10 minus that. If it is not, then straight away that digit itself. So 969, just ignore that. Now 704, this is greater than 8 cube, right? But not greater than 9 cube. So this should be 89 cube root. So that's it. That is cube root. So this itself concludes the cube rooting. So practice this a little bit. Just take your calculators, find a cube, and then take a cube root of that. That's it. And for perfect squares, the process is a little different. So I'll just elaborate this by this way. If you look at 1 square, it ends with a 1. 2 square ends with a 4. 3 square ends with a 9. 4 square ends with a 6, 5 square ends with a 5, and 6 square ends with again 6, 7 square ends with 9, 8 square ends with 4, and 9 square ends with 1. So if you observe this, the 1 square and the 9 square ends with 1, 2 square and 8 square ends with 4, and so on. So and another thing, 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. So in case of perfect squares, there are two possibilities, and the two possibilities of the last digit, I mean, if I'm trying to find a square root, that is. So let us take an example first of all. So let's say 7569. I need to square this number, square root this number, and I observe that the last digit is 9. So there are two possibilities here, right? The one thing that comes straight to the mind should be 3 itself, right? So if it is 3, then other one has to be 10 minus 3. So that is 7. So there are two possibilities. So one is 3, another is 7. Again, as in cube root, we were ignoring the last 3 digits. In this case, ignore the last 2 digits. So once you ignore the last 2 digits, you are left with 75. And again the same process. Which square is just below 75? So that is 8 square, right? So this two possibilities would be 83 or 87. So there are two possibilities now. Now the way to check the possibility, the simplest way that is multiply this 8, I mean whatever you got here as a tens digit, into the next possibility. So that is the next number, that is, sorry. So 8 into 9, and that is how much? 72. Now all you have to compare is the remaining part. So the remaining part, whether that is greater than or equal to 72 or not. If it is greater than or equal to 72, then we take the higher possibility. If it is less than 72, then we'll take the lower possibility. We would have taken the lower possibility. But in this case, 75 is greater than 72. So we will simply take the higher possibility, and the answer would be 87. Let us try with some other example. So let me think of a number. So let's say, okay, yeah, let's take this up. Let's say for 1849, a simple one, that is. So 1849. Again, the last digit is 9, so the possibilities are 3 and 7, right? So you take off the last two digits. Now 18, the one below, the square below this would be 4 square, so 43 and 47. So once you get this, what we have is 4 into 5, so that is 20. Now this 18, this is not greater than or equal to 20, right? This is less than 20. So once it is less than 20, we have to take the lower possibility, so that would be 43. Now please try to understand, we are comparing the left out part with this thing, not this with this. I don't compare the other way around. So if the left out part is less than this calculated value, then there is a lower possibility, and if the left out part is greater than or equal to this calculated value, then we have the higher possibility. So I hope that part was clear. If there is any doubt, you can just comment below. We'll discuss this a little more details. So that's the trick about square rooting and cube rooting for exact perfect squares and perfect cubes. And the estimation of square roots we will discuss in one other video. So thanks again. Keep keep watching this.